Uh, yeah, sure. Am I audible or not?
Yeah,
Can
yeah,
you just
audible.
confirm? Yeah. So, hi guys. I'm Jeet Karya, and I just graduated from Ahmedabad University and done my bachelor's in information and communication technology. And I started as an software engineer at Pivot.ai, which is a early stage startup in the sector of insurtech. And I mainly work there on the back end and integrating cloud services and integrating ML services. So yeah, that's what I primarily do.
All right, happy to have you, Jeet. We have Sharat.
Hi everyone, this is Sharad here. Uh, I I basically work in performance engineering, site reliability engineering, and machine learning at Cognizant Technology Solutions, Bangalore. And I'm really interested to know more about Litmus Chaos.
All right, thank you for joining in the call, Sharat. We have Vishal.
Yeah, hi everyone. This side Vishal, and I've been working in DevOps field from last 5 years. So I'm basically working with Kubernetes and other open source technology revolving around it. That's it. Thanks.
Thank you so much. We have Priya. Priya, would you like to introduce yourself? Okay. Sure. We can take up the other introductions later on this call. So yeah, good evening and welcome to Litmus Chaos Community Sync-up for the month of June. Moving forward, we can look at the agenda that we have for today. So first of all, we have our release note discussion, June edition by Adarsh. And then we have two demos, which will be done by Aman and Akash respectively. And then we can have the question answer round, but still you can put down your questions in the chat box and yes, we'll be good to go. Yes, so Act 1, release notes. Adarsh, you can share your screen. Just a second. Yeah.
Sure. Thank you. So, hi everyone. I am Adesh Kumar. I am software engineer at Harvest, and I'm also one of the contributors to the Litmus Chaos. So, let me first share my screen. I believe my screen is visible.
Yes, Adarsh, it is.
Yeah. So today we have released Litmus 2.10.0. So in this release, we have added HTTP kiosk experiment for Kubernetes application using proxy, and this will allow you to introduce latency in the target application service and check the application availability. And Akash will show the demo of this experiment today. And we have also introduced first beta version of Amazon, which enables us to run kiosks on non-KTS targets. It also includes a new CPU experiments that can run CPU kiosks on the target VMs. And we have also added stress image parameters that is missing in our pod IO stress experiment, and that enable us to add custom stress image of the experiment using Pumbaa library. And we have also enhanced node code and experiment. And when we were checking the app status, it was failing during the chaos. So now it will pass. So and after that, we have also fixes the chaos result verdict update for the GCP dislogs experiment by label experiment. And we have also fixes node level E2E checks for every build on the PR for the Litmus repository. We have added docs for the newly experiment HTTP chaos experiment. And we have also updated the GCP experiment docs. And we have also introduced some more examples in the docs for the pod network latency experiment with GitHub. We have added chaos chart for AWS AZ uh, down experiment in Hub. So in Hub, you can see there are two more experiments that have been added here. So we can find AZ failure from name AWS AZ kiosk, and you can find HTTP kiosk with the name pod HTTP latency. And these are the updates from the core side, so from the chaos center side. So earlier, in GraphQL, all the queries, mutation, and subscriptions are in the same file. So there will be some trouble in the debugging and scalability. So we have uh, differentiate all these queries depending upon their functionality. And we have also added a support for invite proxy when using frontend. So earlier we were using the distributed proxy for version 1 that is only supported for the engineers. So we have updated to the 1.1 to support invite proxy also. We have also added UI enhancement for allowing scrolling to invitation tab after clicking on the invitation button. So let me show you that. So this is the Chaos Center, and it is version of 2.10.2. So when you go to Teamy, and if there is an invitation, and when you click on that invitation, you will directly go to the invitation part. So we have added this functionality also. And apart from that, there was an issue when we are adding any probe, just like KTS probe, HTTP probe input is adding to that probe. That's why that probe was failing due to that, because due to the passing issue. So we have also fixed this issue. Now all the probes, KTS probe will also work properly. And we have also earlier in scheduling, if you are scheduling workflow, if we are passing some, just let me show you. So when this is my chaos center, so when just let me schedule a workflow. So while scheduling a workflow, when we just selecting potato head for the demo. So in schedules, so in recurring schedules, while earlier when we even there is, if you don't select any of the parameters, the experiment we are able to go to the next and run the experiment. So we have also refactored this issue, and now you have to select, if you are selecting recurring schedule, that when you want to schedule your workflow. And after that, so there was one problem in the GitOps, that when we are editing the GitOps, it is cloning into the another repository that we are not mounting to our GraphQL server. So that is also in this release. And this is we have added a ENV in GraphQL server, that is Chaos Center UI endpoint. So earlier we all are facing issues in agent plane, that we sometimes we have to go manually edit the agent config and provide the endpoint of our Chaos Center. So we have added ENV in our latest manifest. So where you can just provide the endpoint of the Chaos Center, and subscriber, the agent plane will auto fetch that endpoint, and it will connect the Chaos agent. And we have also added image pool secret for engine runner and experiment for from the image registry. So earlier with the image registry, it is adding the image pool secret and all only on the workflow level. So with this release, we have added image pool secret for engine runner and experiment for. So let me show this also. So as you can see in settings, image registry, I have added one custom image registry. So when I go to Litmus workflow, just scheduling a workflow here, selecting Litmus yourself for now. Yeah. So just I'm adding pod delete experiment here. Okay. As you can see, pod delete experiment has been added. So when I go to edit YAML and in engines, as you can see, it is added here. And in experiment also, you can see experiment image pool secret is also added. So earlier only this image pool secret was added. So this is only for the workflow level, or the image pool secret has been fetched for all the workflow level pods, but for the experiment pods and runner pods, we have to do manual patching. So for that, we have added the field for image runner and experiment mode also. So yeah, so these are all the updates from the Kiosk Center side. And so we have also have done the Litmus CTL release. We have released Litmus CTL version 0.11.0. With the release, you can do the CRUD operation over workflow. You can get the workflow using Litmus CTL. You can create the workflow. You can describe, delete, and get the workflow runs. And we have also added functionality to delete agent from the Kiosk Center also. So earlier there is only one functionality that Litmus CTL can connect agent to the Kiosk Center, but with the Litmus CTL now you can disconnect the agent also. And we have updated the Litmus CTL create command to the Litmus CTL connect command. So this is the please take a look into this. So this is now you can connect the agent using Litmus CTL connect agent. And we have also enhanced logging in the Litmus ETL for better debugging. So if you are using Litmus ETL version 0.11.0, so make sure that you are using Litmus version 2.10.2 or higher version, else it will not be work for any Litmus version lesser than 2.10.2. So yeah, these all are updates from the release of 2.10.2. So is there any question? Yeah, so that's all from my side. That's it. Thanks.
All right, thank you, Adarsh. If we have any other questions, we can post it in the chat, or you can just unmute your mic and ask. Moving forward with the demo that we have, Aman.
Yes.
Yes, you can proceed.
Yeah. Let me share my screen.
Okay.
Yeah. I hope my screen is visible.
Yeah.
Yes. So firstly, thank you everyone for joining in and a very warm welcome. So I will be sharing the update of my work, which we did in Litmus E2E as a part of enhancement in our latest release. So Litmus E2E is the end-to-end testing framework which we are using for Litmus. So for this end-to-end testing, we are using Cypress. Cypress is a JavaScript end-to-end testing framework which we are using for the end-to-end testing. So this is the repo, Litmus E2E repo, where we have all the tests. So earlier what we had was some E2E test which test everything from start till the end, like how the user logs in, he creates a workflow, manage it, and then he checks the final result. But what we were missing was the API testing. So in this release, we have added the API test for them. So currently we have two API in Litmus. One is a REST API, which is the authentication API, which manage everything like the login, password, and project management thing, like these things. So these are managed by the REST API part. And other, we have the GraphQL API, which manage all the core functionality offered by the Litmus, like the Chaos Hub, the workflow management, scheduling agent, and workflows, and all those stuffs. So for these two testing were earlier not available, which we have added in this enhancement. So let me show you the code. So this is our E2E repository. So here you can see in the folder structure that inside the integration, we have now added this API test folder, which contains two folders, authentication and GraphQL. The authentication contains the REST API test, which is the project related specs are in the project spec file and user related specs are here. And GraphQL, we have maintained the code in as modular and as user friendly as possible. So here you can see the cluster test and all those things, and all the constants are declared in the fixtures. All those things which we are using constantly are constant around the thing, like all those input which we are providing to the user or to the like my hub or the image registry input. All those constant are present inside the fixtures, and all the queries are inside the GraphQL folders, like the mutations and the queries here, so that in future if we change any query or update any small thing, we don't have to update it at many locations. We just have to update here in one location. So that's why we have kept it that modular way. So let me show you one particular test and show that how we are proceeding. So the test work like this, that before we create any test, the first thing which runs is the before part. So it does some general setup for the test. At before setup, some basic things need to be set up before the test can be run. So the first step is clear database. So earlier this function was not present, so we have to manually clear the database, and due to this it was not possible to run multiple tests simultaneously or one after the other. So now what we do is we first clear the database, the complete MongoDB database, and just the user login credentials remain there, so that everything works like a clean, fresh installation. Then we log in the user with the admin credentials, the admin username and password, which are stored in the fixtures folder. Then get started thing, it change the first time login. When you logged in, it pops you up a screen which shows you that do you want to change your password. So this particular functions sets the password as Litmus itself. So we have kept everything model because these things would be required in many other places as well. So that's why we have created separate functions for them and just calling those functions here. Then get admin project, it gets the admin project details, set security setup. So this is a very common function which we are using at many places. So what this function does is it creates a basic layout. So this layout is like this. It creates two projects. One is project 1 and one is project 2. So project 1 has admin as the owner, user 1 as editor, and user 3 as viewer, because we need to see many other different scenarios, like can a viewer access person should not be able to access those things which they might not be able to access, so that user should only have access to viewer related things, not more, not less, and editor access things and owner access things. So for that we need to create some users and some project, so that we can check that whether the user 2 which is in project 2 should not be able to access anything inside the project 1. So for these things we are currently have created such a particular setup. So this function creates that setups, and then we test everything, like uh, whether we are able to create an image registry with a user with viewer access, with a user with no access, with a user with admin access. So at every level we are checking that for all the access whether this thing is possible or not. And for that we first log out and then again log in, and we send the request using Cypress with all the particular data. And here in the then part we check that whether the response is as expected or not. So this is about the basic code structure. So here we have now added everything for these two particular APIs and test added for them. And now we have also created the pipeline, API pipeline for them, so that now whenever a person creates a pull request or a new commit is added, so at that particular time only these tests runs, and the maintainer can check that the new commit or the new code which is added does not breaks anything, does not break any particular API. So this also ensures that the code is always production ready and is free of any possible bugs. And and writing quality test case was also an important task here, because this also ensured that the project has no bugs. Because while writing this project, while writing these test cases also, we found few of the issues which were reported and now fixed. So this also improves the project quality and ensure that the project is bug free. So these were all the updates which we have added in the E2E sections. And in the future enhancement, we have added this pipeline, and this pipeline is merged. Later, some of the few things like will be enhanced, like these user details which we are adding manually. This project setup, we will be directly adding it in the MongoDB database and directly seeding the database. Currently, we are adding it through the API, so testing the API. But later, we would be adding it directly to the database, and few more enhancement would be added later. But currently, we have everything, all the API tested completely, and we have added the GitHub pipeline for that as well. So yeah, that was about the API testing. I would be happy to have any questions or queries to answer.
Thanks, Aman. I think we don't have any questions as of now. Thanks for this great presentation and work done on the tool dashboard side. We hope to get more such contributions from you. Perhaps with this, I would request Akash to take up the next agenda item for today. So, Akash, the floor is all yours.
Thank you, Betsy. Hello, everyone. Uh, so let's get started with HTTP chaos. So right now we have the HTTP latency chaos experiment in the HTTP chaos category. So this experiment basically adds a latency for a given value to the HTTP request that is coming to the service. Okay. So first of all, let's get started with the demo, and after that, I'll explain how we are doing this internally, right? So I'll just go ahead and schedule a workflow. Before that, I'll show you on what service I'm going to inject this. So I have an Nginx service, basic Nginx for running on my system here. Okay, so I've created this as a load balancer and it is available on the port 80 with this external IP, right? So I'll access this using this external IP here, right? So right now we can see it's accessible. There is no latency, and as well as I have this script here, which will basically curl the IP and give us the total time or the time it takes to load the page, right? So if I just run this script right now, I can see there it takes around 0.5 seconds or 0.6 seconds to load this specific web page, right? So there's no latency or there's no downtime, right? So what I'll go is I'll go ahead and start the kiosk with HTTP latency. Right. So let's add the experiment. So I'll show you what all fields we have here. Right. So the tune experiment part, you have this latency column, which basically is a latency value you can provide. So let's provide. So this is in milliseconds. So this means there will be a 3-second latency. The target service port is basically the port on which your service is exposed at. So as I showed, like my service, it exposed at on port 80, right? So I'll be giving the value at 80 for the target service port, right? And we change these values to container D. Right? So there's one more environment variable to enable available, which is called the proxy port, right? So this is basically the port on which the proxy service will be listening to. Okay, so it's like it's not a requirement to change this. You can use a default value. Only it's required to change if the default value is being used by some other service or by some other uh, uh, some other service or by some other thing in your node, right? So by default, the value provided is 20,000. So this will basically act on 20,000 port. Okay. So I won't be changing this value here because I have that port open. So just finish this and let's verify that I provided the correct details. Okay, feed latency, container D, and the container proxy value. Okay, great. Finish and then just start the experiment here. We have this workflow running here. So when this start, I'll show you what all commands it also runs inside the pod, and then I'll just start this well command now. So we have this total time loading at 0.5 to 0.6 seconds.
Hey, while that loading, I have a quick question. This is Raj. Can I ask the question, or you want me to save questions towards the end?
Okay, so it's the experiment is starting. So let's take this
Okay.
after. Okay.
Sure. Keep going.
Okay, so now this will start the helper pod. Great. So we have the helper pod running here. So we would be seeing latency coming up in the service. Yeah, soon. Meanwhile, I just add the logs here to see. Yeah. So there are 3-second latency added to HTTP requests, right? And these are the helper pod logs. So you can see like, so what we're doing here, I'll be explaining this to a diagram as well. So first we are starting the proxy server, which we're using Toxi proxy to inject this. And then after that, we are also adding an IP table rule set, which basically redirects the request from the port of the service to the port of the proxy server running, right? So here you can see the proxy server is listing on 20,000 port and the upstream URL is 80, right? So this will basically, any request coming on 20,000 will pass through proxy server and will be forwarded to 80 with any changes that we made. And this IP table rule set will provide us this. So if I try to access this service on port 80, I can see the latency coming in, right? So this latency you can also see here in terms of this bash request script, right? So I think we are done with, yeah, so it's done. Yeah, so you can see it's back on track with the before the values it was, right? Yeah, so now we have this experiment completed. Right? So I'll just show you how we are doing it internally as well. So what's happening, like without, when the proxy is not running, what's happening is whenever you access service, the request directly gets forwarded to service A, right? What we are doing with this is so previously in our first iteration for HTTP chaos, the user were like the whenever you injecting we were required to change the port to access this, right? So we basically had to access the proxy port, not the like not the service port directly. Then only we could have this HTTP chaos, right? But now with this IP table rule set routing, we can even like we don't have to change the port value. So if you have two services that are talking to each other, right? You don't have to change the port value for the service to the proxy service, right? So what this will do is basically we add an routing rule, uh, which you can see here. So what this routing rule does it, whenever request comes in, it basically directs that depending on the port. So I provided port 80 here. So any request coming to port 80 on the pod will be redirected to port 20,000, which this port 20,000 is basically the port of the proxy, right? Proxy server, which is listening to it. So this is basically on which the proxy server is listening to. So for us, it's listening on 20,000 here. So let's make this 20,000, right? And then the proxy server will forward that request to service A, and we can modify that request as per our need. Okay. Then and as well as a response, right? So then that response will be sent back to the user. So that is what we're seeing. So currently this HTTP has only the latency experiments, but in subsequent releases we'll be adding more experiments related to HTTP chaos, like experiments where you can edit the response code of the service. So if you want to change the response code, or you can change even modify something inside the body, or add an header or modify an header, or maybe delete an header, right? So these in the request and response both. So these kinds of function experiment will be added subsequently. So this is the start of the HTTP chaos category with the latency, and further on we'll have more experiment which can do this. Yes. So yeah. So now I think we can take up questions.
Akash, this is just great. This is awesome. Actually, you answered my question. My question was, or you answered one of my questions. I have other questions as well around modifying the HTTP request response headers and body and all. So that's coming in future. That's great. So when you're doing your demo, you showed the configuration of target port number, right? But your pod may be talking to an external system, completely the system running outside of your Kubernetes platform, for example. Can we kind of configure IP as well so that you can simulate HTTP chaos on the endpoints?
Yes, so this is something that we are trying to achieve. So the issue, so we have a certain issue with this. So like if you have two services running and you want to inject HTTP chaos between the services, suppose like 1 second, right? So suppose like if I have another service B running here, right? And so I want the connection between these two services, right, affected by this proxy, affected by HTTP chaos. That is what you are asking, right?
Yep. So service A, when you say service, so it could be a Kubernetes service. Service A could be a Kubernetes service. Service B could be running outside of Kubernetes platform, right?
Correct. Yeah, so this is something that we're trying to achieve with this right now. Currently, you can, like, if you want service A to be affected, right? All the requests coming to service A will be affected. So right now, filtering it based on IP or path is not available in current release, right? So filtering based on path is something that we have in the pipeline. We're trying to achieve that. And another is this specific part where we are trying to, like, if service A is talking to service B, right? And we only want to affect this specific connection and not any other connection. Like if I access service B directly or by some other way, this will work fine. But if I access it using service A, right, this won't work properly. So this is something that we're trying to achieve. We have some issues with this because if we try to use a routing table here, it was basically going into a loop because since if we add a proxy server in between this, the proxy server will also send an outgoing request to service B, which will go through the routing table as well. So that will become a loop inside the pod, service A pod itself. It won't go to service B. So we are trying to find a way that we can achieve this specific kind of filtering based on two service talking to each other. So this is something that is what you are asking, right? Or if your question,
right? So it's more of a so if I can phrase it, what you just said, you can create a HTTP chaos on inbound request on a service A or a pod hosting a service A, but not the outbound traffic, essentially, right? Where you are you seem to have some problems simulating HTTP chaos and outbound that you are working through.
Yes, correct.
Yeah, so our requirement mostly outbound. Yeah, there may be inbound also. So if the service A and service B both running in Kubernetes, right? I can create a chaos on service B inbound that would meet my needs. But if the service B is running outside of Kubernetes, I need to set up chaos on the outbound of service A, right? That's what I need. So I have both the needs, I should say. Right?
Correct. Yeah. So like for inbound service, we have like this HTTP chaos right now works for inbound services, but for outbound, right now the support is not there. But I guess if you find a solution, whenever you find a solution to that, we will be having the service as well for outbound requests as well.
Okay.
That is.
And one more question: when it comes to latency, so what's the difference between the network latency versus the HTTP latency? They will be very similar, right? From underlying code perspective.
Yeah. So if you see it in terms of like the output you're getting based on the chaos, so HTTP latency and network latency are very much similar, right? So so with latency, you can have the outbound thing in outbound request in network latency, right? So HTTP latency is like a starting stone for HTTP chaos and Litmus chaos, right? So this basically puts up the base for the further experiment that are more inclined towards what actual HTTP requests are about, right? So the further experiment that will be coming up in will be more inclined towards editing and modifying HTTP requests directly, right? So they'll not
Got it.
be limited to mostly network related, but majorly on based on HTTP. So this is just a foundation stone for HTTP chaos. Further on, the experiments will be more inclined towards HTTP modification, request and response modification.
Got it. Got it. Makes sense. Thank you.
Great. So if you don't have any questions,
I have a question related to one of the issues that I'm running into.
sure.
Sure. So this has also been posted in the Litmus community channel. And what's happening is I'm using a custom PSP because I have a restrictive PSP in place. And the issue that I'm running into is the runner pod uses the custom PSP, but the experiment pod itself, it uses the other PSP, which is the restrictive one, and because of which my experiments are failing. Correction, pod delete is not failing, but the other experiments like container kill or network latency experiments, those are the ones failing. And I checked to make sure that the chaos engine is using the right service account. In this case, I'm just using the pod delete service account for now, and I'll keep adding additional permissions to it as and when I need it. But for now, I'm using the pod delete service account, and this is the one that's tied to the custom PSP correctly. So any suggestions on what I should be checking? Hello?
Hey, hi. So here, Vedant. So I suppose I think pod read is working because that doesn't involve the helper pod. So that's why it is working fine in your case. For providing the service account, because I think that is what you are using for assigning the PSP as well. So when you are providing the service account, are you providing a service account in the engine, the variable chaos service account? Are you modifying that one?
Yes. And whenever I'm creating the experiment YAMLs as well, I made sure to add the chaos service account and update it to the new service account that I'm using as well. So it's present in both places.
Okay. Maybe one thing that you can check is because the other experiments that you are trying to use, the network latency and the container kill ones, they involve the helper pod. So when you're running the workflow or the experiment, maybe you can just describe that pod and check if that pod is having the service account that you gave from the engine.
Oh, it's not. It when I do a describe on that pod, so the runner has the correct PSP, but when the runner tries to launch the actual experiment pod, that one is using the other PSP, and the error message clearly states that the PSP is not admitting the pod. So, and when I do a describe on that actual experiment pod, it uses the restrictive one. So
Okay, so you're saying the experiment pod is also not having that one, the service account that you are trying to use.
Yeah, I'm checking the PSP associated with both the runner pod and with the experiment pod. The runner pod uses the new PSP that I created, but the experiment pod, it's using the restrictive PSP, and because of which it does not complete.
Okay. Yeah, I think as Remy said, maybe we can talk about this on the channel. Maybe some configuration issue is there. We can take a look.
Sure. Okay. Yeah, that'll be very helpful. Thank you.
Sure. Thank you.
Thanks everyone for those amazing questions. I'll just open the floor for any other questions if we have any, or if there's someone who wants to share anything, any experience with Litmus or anything else regarding Litmus, and then we can wrap up today's community call. So is there anyone who just wants to introduce himself or herself and just add to their Litmus journey or something they have been working on? or if you have any questions. Sure, Remy, you can ask your question. I guess Remy is asking, is there any way to set limit requests on the chaos workflows? Can you take that up?
Rami, I think from our side, we don't limit anything. So you can run as many workflow as you can.
Well, hello everyone. Sorry. In fact, we have some policy in place on the cluster, and we are not allowed to deploy any components without limit requests or without specific label. Any way to set this limit request via pod resource or something? I read some documentation, but I didn't. I didn't success. So
Okay. You mean the resource limit? Okay.
The question is about the resource limit for we have for operator and other steps, but you are asking for the runner and the experiment pods, right? It's like engine pods, whichever you are running.
well, since the CRD, the Argo CRD workflow is created, the operator tried to launch the workflow with number, and our server rejects the creation of the pod because it lack of limit request.
Okay, got it. Raj, the question is about it's like when the workflow gets launched, the new pods comes up, right? So those things request limits to be set.
Okay.
Nice.
Yeah, it's a good enhancement request. Can you raise a issue on Litmus channel? It's like Litmus repo, Remy. We'll try to take a look on this one.
Yes, I will run an issue and publish it in the Slack.
Yeah, sure. It would be good if you can raise a GitHub issue as well.
Okay, thanks.
Hi team, my name is Shweta. I had one question. So it's not an issue, but just wanted to understand like how we can mitigate the observations, kind of say with respect to the network experiments. So if you're doing network latency corruption or loss, we know that there will be latency, added latency on the traffic or errors. But in this case, is there any way that we can resolve the errors that we observe or say mitigate such kind of issues? What can we do for that? Any idea if you have would be really great.
Shweta, if I understood correctly, so if there is a network errors, you inject and the corrective actions has to be taken, right?
That's right, yes.
Okay, maybe it's not that, it's like we don't have the native capability, but you can use probes is one way you can try it out, like as part of the probes, when you hit some scenarios, you can have a command probe to do certain kind of execution. So that
yes, so yes, that's right. So this is not with respect to like not trying to get any kind of capability from the Litmus tool, but want to understand if you have any idea on how we can mitigate these kind of issues if we see in our environment, right? Do we have any idea on how we can mitigate or kind of resolve that these kind of issues do not interrupt with the traffic or the performance?
Uh, Maybe I'll leave question to others. One thought process was like to have some kind of probes or similar to that a logic we have to write out where it continuously monitors and take a corrective action on top of that one. But that may not be that effective solution what I am referring right now.
Okay, Ajesh.
If we are not having any more inputs to Shweta's question, perhaps we can have a conversation with Shweta later on Slack, and maybe Shweta can post this question on Slack as well, so that anyone from the community can just jump in to respond. And with this, I think we come to the conclusion of today's community sync-up call. Thanks everyone for tuning in and asking your questions, being a part of this, and we hope to see you once again next month on the third Wednesday of the month. So thanks a lot everyone for staying back for so long, and happy chaos engineering once again with Litmus Chaos. Thank you so much.
Thank you.